All right, guys, I got kind of a laundry list of questions here towards the end of the homework assignment. I'm just going to jump into it. The list of the ones that I'm doing are right there at the top. First one starts off with this natural log of the square root of a rational function. So I'm seeing like a rational function within a square root function within a log function. The first thing I think I would probably do would be to change this to the 1/2 power. And then as far as just starting outside looking in of the natural log function, the derivative of a natural log function is just 1 over this. So I can't remember, 95 was y equals. So we're going to say y prime starts with 1 over this nonsense. So geez, do I want to bring back the square root? I might bring back the 1 over the square root of x plus 1 over x minus 1 times the derivative of what's inside, which is this thing. Now the derivative of what's inside is going to take a power rule. Bring the 1/2 out in front of said rational fraction, drop that 1/2 by 1, goes down to negative 1/2, times the derivative of what's inside of that. That's going to be nasty because that is a quotient rule. So I'm going to use some brackets for organizational purposes. Bottom times derivative of the top is times 1 minus top times the derivative of the bottom, which is also 1, all over the bottom squared. All right, so as far as cleanup, I'm gonna, I'm still struggling with whether I want this to be a radical or an exponent. I'm gonna go with still keeping it a radical, not touching that, times the 1 over 2 I'm gonna keep. The negative is gonna flip this. So it's going to be x minus 1 over x plus 1 to the 1/2 power. But actually, I think if I just take this and move it into this one's denominator as a positive 1/2, then it will almost be more common with that one. So I'm going to do that. I'm going to move this into a denominator. So it'll be x plus 1 over x minus 1 to the 1/2 power, which is the same as that. So I've kind of got something that I like there. Times my numerator over here is just, let's see, x minus 1 minus x minus 1. So the x's cancel and it ends up just being negative 2 over x minus 1 squared. So when I do my multiplication of fraction times fraction times fraction, I get negative 2 on the top. Well, let's cancel that 2 with that 2 right there. So negative 1 on the top. And on the bottom, this times this is just going to cancel the square root. So it would be x plus 1 over x minus 1 times this. And then this one on the bottom cancels with one of the two of these on the top. So we end up with negative 1 over x plus 1, x minus 1. Back of the book is slightly different, so they must have multiplied this out. Negative 1 over x squared minus 1. And yeah, instead of having the negative sign in the top, they sort of move it to the denominator, which flips the order of this. So they have 1 minus x squared as their answer in the back of the book. On to 97. Oof, God. You see, my workday just got started when I put the kids to bed. And, whew, it might be up longer. This video might be longer than I want as I'm looking at these. All right, so that doesn't look very nice. We got two pieces here. So derivative. On the first one here, I'm going to do the quotient rule. So I'm going to focus here first. Bottom times the derivative of the top. Now the derivative of the top is going to be where the chain rule is needed. I'm going to rewrite this square root of x squared plus 1 as it being raised to the 1/2 power. So the bottom times the derivative of the top is going to be negative 1/2 with x squared plus 1 to the negative 1/2. So that's me applying the power rule times the derivative of what's inside, which is 2x. So bottom times derivative of the top minus top times the derivative of the bottom, which is, thank God, 1, so I'm not even going to write that, all over bottom squared. Plus, I got to go and do that, which I will. Just give me a minute here to see what I want to do with this one. This, I'm going to let the 1/2 and the 2 cancel. So I have a negative x squared times x squared plus 1 to the negative 1/2 power. I'm going to let this become a plus. Okay, so that's the first part, plus the derivative of the second piece. So the derivative of ln is 1 over whatever this is. Times the derivative of what's inside, and the derivative of what's inside is 1, plus the derivative of this is a chain rule within a chain rule, because the derivative, this is technically x squared plus 1 to the 1/2 power. So the derivative of that is 1/2 x squared plus 1 to the negative 1/2 power times the derivative of what's inside of that, which is a 2x. So when I clean up over here, I'm going to leave that alone for a second. Times the 1/2 times the 2 is going to cancel again. It's going to be 1 plus x squared plus 1 to the negative 1/2 power. Okay, so the cleanup, that negative is not really clear. Cleanup is going to be challenging. So let's see how I want to do this. Let me start here, because we can create a complex fraction and maybe clear the complex fraction. So I have negative x squared over root x squared plus 1. I want the 1/2 back to a root, plus root x squared plus 1 all over x squared. And if I can clear that complex fraction, multiply by root x squared plus 1, root x squared plus 1, and I get negative x squared plus x squared plus 1 over x squared root x squared plus 1, which has the benefit of the negative x squared and the positive x squared canceling. 1 over x squared root x squared plus 1. Okay, left part only. Oh, this is hilarious. Plus, on this one I have a fraction times a non-fraction, although this was a negative, right? I was afraid that that was going to blend in and I wasn't going to see it. So again, if I wanted to write this as a single fraction, this would just be my top. So my top is 1 plus x over, because I'm going to move this into the denominator. So I'm doing 1 times this is going to be my new numerator, all over x plus root x squared plus 1, because that's technically over 1, But within the numerator, I'm getting rid of this negative 1/2 power, and I'm going to put it over root x squared plus 1. Again, clearing the complex fraction, root x squared plus 1, root x squared plus 1 gives me root x squared plus 1 plus x over, when I distribute down here, I'm going to get x root x squared plus 1 plus x squared plus 1. Now, in order to add these fractions, you know what, I'm going to back up, thinking of all, like, how am I going to get a common denominator from here to here? I think I'm not going to distribute that, because if I don't distribute that, then I already have somewhat of a partial common denominator of x plus root x squared plus 1, and then root x squared plus 1. So they already have that in common, which means this side needs an x squared, and this side needs the x plus root x squared plus 1, which isn't so bad because that's just getting multiplied by a 1. So my numerator over here is x plus root x squared plus 1 plus my numerator over here is x squared root x squared plus 1 plus x cubed all over x squared root x squared plus 1 x plus root x squared plus 1. I have x plus root x squared plus 1 plus x squared root x squared plus 1 plus x cubed. God, this is awful. No wonder so many of you asked about 97. I think I'm going to take a closer look at this and then get back to you. I'm doing these live because I did not want to do them on a separate sheet of paper and then don't go and do them again on a video, because that would double my amount of time. So this one I need to think more about. Let me go back. I wonder if I went wrong at some point and didn't realize it. But where I am right here, not all 4 of these terms have anything that could be factored out. So I wonder if I could do, well, no, I can't do grouping. I just don't remember this one being this difficult in years past. But let me get back to you on this one, because that's definitely not the answer in the back of the book. We will carry on, and I will get back to you on 97. Make myself a big note star. 103 is another one. Okay. Y equals ln of negative 1 plus sine x over 2 plus sine x. And with logs, this has to be positive anyway. So these absolute value signs, as we saw in the notes, are pretty pointless. The derivative of ln of the absolute value of x is still 1 over whatever it is. So it's 1 over this. Now 1 over a fraction just really flips the fraction, so I'm just going to do that for the 1 over it part. Times the derivative of what's inside, which is going to require a quotient. So we have the bottom times the derivative of the top, which is 0, and the derivative of sine is cosine, minus, and thank God there's not a chain rule here because it's just sine x, not sine of something more complicated. Bottom times the top minus your top times the derivative of the bottom, derivative of sine, again, is cosine, all over bottom squared. So the first thing I see is 2 plus sine x here times this fraction, 2 plus sine x squared here, so one of those is going to cancel with this one. My numerator is a 2 cosine x plus sine x cosine x. I'm going to treat this distribution as a negative cosine. So plus cosine x minus sine x cosine x all over negative 1 plus sine x and 2 plus sine x. And we get a plus sine x cosine x minus sine x cosine x. That's going to cancel. Total on top is 3 cosine x over, this can be written as sine x minus 1 and 2 plus sine x, which is the answer in the back of the book. So we're good there. You guys are really testing me. I blame Mr. Hill. Don't tell him. All right, so they want to know in 107, describe and correct the error. So I'm just going to find my own derivative. I'm going to open up with a quotient rule. So bottom times the derivative of the top. So the derivative of the top is ln of 4 times 4 to the 3x times 3, because you know the derivative of what's inside, minus the top times the derivative of the bottom, which is just 1, all over bottom squared. So from this minus this, we can factor out a 4 to the 3x, and we're left with 3x ln 4 minus 1 all over x squared. 113. Find and evaluate the derivative of the function at the given point. Okay, so f of t equals 3t plus 2 over t minus 1. And they want us to evaluate it at 0. So they essentially, 0 comma negative 2 is the point. So they want f prime of 0. Okay, so f prime of t, bottom, times derivative of the top is just 3, minus the top, times the derivative of the bottom, all over bottom squared. And then a quick cleanup is going to make it 3t minus 3 minus 3t minus 2 over t minus 1 squared. So negative 5 over t minus 1 squared. And when I evaluate that at 0, I'm going to get negative 5 over negative 1 squared, which is negative 5. I wonder what the hiccup was on that one. That one wasn't even a chain rule. That was just a basic quotient rule. But 115, yuck, y equals 26 minus secant cubed 4x at 0.25. They want the derivative at 0. So again, I'm going to see this as the secant of 4x being cubed. So when I go to do y prime equals, so the derivative of 26 is just 0, so who cares about that? But when I do the derivative of this, I'm going to start with the power rule. It's minus something cubed. So bring the 3 out in front, drop the cube to a squared, and then multiply it by the derivative of what's inside. And what's inside is a secant function. The derivative of a secant function is secant tan times the derivative of what's inside of that is times a 4. So overall, this whole thing becomes a negative 12 secant cubed of 4x times tangent of 4x. Now, x is 0, where we want to evaluate this one. So if you plug in a 0, the tan of 0 is 0. So 0 times, who cares what else, as long as this isn't undefined, and this is 1 over cosine cubed of 4x, and the cosine of 0 is 1, so it's not undefined. When you plug in 0, because of this, 0 times all the rest is just going to be 0 is your answer. 117 wants us to find an equation of a tangent line. So we need a point and a slope in order to write an equation of a line. Use a graphing utility to graph the function and its tangent line, and use the tangent feature. We don't need to do that part. So we're just going to write an equation of a tangent line at the given point. So in 117, our function is this. And they want the equation of the tangent line at 4, 5. So we already have the point. We just need to find the slope. And in order to find the slope, we need to find f prime of 4. In order to find f prime of 4, we need f prime of x. So I'm going to rewrite f of x as that. So f prime of x is going to proceed by power rule first, times the derivative of what's inside, 4x. And so the 2 and the 4 will reduce, and it ends up being 2x over the square root of 2x squared minus 7. We don't need to do much, just plug in 4. So f prime of 4 is 8 over the square root of 2 times 4 squared is 16 minus 7. 32 minus 7 is 25. 8 over root 25 is 8/5. So our slope is 8/5. And the equation of our line would just be y minus y1 equals your slope, x minus x1, and then if you want to distribute it and then add over your 5 to get it in point slope, you're good to go there. Last one, 123. Same set of directions. Write the equation of a tangent line. But the function is a heck of a lot uglier. And it's at 0.04. So we need just to find our slope. And we have to do that by finding our derivative. So y prime is going to equal, derivative of 4 is 0, great. Derivative of negative x squared is negative 2x, great, minus. The derivative of ln is 1 over a half x plus 1 times the derivative of what's inside of that, so times 1/2. You don't really need to clean these up because all we're after is the slope at 0, so you can just plug in 0, and you're going to get 0 minus 1 over 1 times 1/2. 0 minus 1/2 is negative 1/2, so your slope is negative 1/2, and then you go ahead and you write the equation of your line with that. Actually, that's your slope and y-intercept 0, 4, so it's just y equals negative 1/2 x plus 4. So, whew, that was like almost a whole nother class going over these. So let's Stay tuned on 97. I got to go back and look at that, but we won't let this get any longer than it already is. Enjoy.